Tech Jacks here. This video is the OSPF basics. We're going to take a look at the advertisements, Link State Advertisements, and learn a little bit about what they're used for and how they help us to determine what's going on in our environment. So let's go ahead and start and see what it is that we're working with here when it comes to Link State Advertisements. There are 11 different type of Link State Advertisements. And they help communicate information between the routing topologies and the routers. These advertisements obviously have different criteria in terms of what they're generated by, when they're generated, and things like that. So we'll be able to go through those individually and determine what we need to in order to have a good grasp about what they're for and what they help us do. The ones that we will be looking at in this particular video will be the first three, because it's a lot of information and I don't want this video to be too long. So let's go ahead and jump right into it. We're going to take a look at the type 1, type 2, and type 3. The first type of link state that we're looking at is the router link state. Every router in an area is going to generate a link state advertisement type 1. And what this allows us and allows the area to know is what the router ID is for those routers in that area. They are the first type of actual LSA that shows up when you do the show IP OSPF database command. Routers connected to more than one area will create a type 1 for each area they are a part of. That's how each area knows about all the router IDs in that area. So if it's an area border router and it's a part of multiple areas, that router will create a type 1 for each area it's in. There are a couple of commands. The show IP OSPF database is more of a summary about the link states, whereas if you use the show IP OSPF database router command, you're going to get a lot more detailed information. So let's go ahead and jump into a topography here and take a look. Okay, so this topography is a topography I used when I was learning a little bit about this stuff, and I just created different areas and stuff and added stuff on as I needed to see how it worked. So let's go ahead and use this. It has everything that we're going to need to explain some of this stuff. We're going to do a show IP OSPF database, and we're going to do this command on our St. Louis router here. And it's an area border router because it's between area 0, it connects to area 1, and it connects to area 3. And the first information that you're going to see is the router ID and the process ID of OSPF. You're going to also see the router link state area 0. And that lets us know that we're looking at the link state advertisements for router link states in area 0. We have link IDs, advertising router, the age, sequence checksum, and links. So here's what we're looking at right now. In area 0, each router will create a LSA type 1, and those will show up in our link state database. So let's take a look. We have a 15.15.15.15 being advertised by 15.15.15, and that's St. Louis. That's St. Louis's router ID. It corresponds to the ID that shows up there, and that's what I configured it as. We have a link ID of 16.16.16.16 being advertised by 16.16.16. So as you can see, there's a pattern here. The link ID and the advertising router, those are the type 1s being generated by those IDs. So we have 1, 2, 3, 4, 5 different router ID type 1s in area 0. So we should have 5 routers, right? We have St. Louis, Chicago, Detroit, DC. So that's 4. This switch isn't going to be generating any type 1s. So why is it that we have 4 routers, but we have 5 router IDs, type 1 showing up? And the reason that is because this Austin router is actually created a virtual link between Austin and St. Louis. So that's why it's showing up. It's flooding its type 1 into area 0 because it's being used to help area 24 transit area 3 and become part of this OSPF domain. So when you set up a virtual link, it creates a logical interface that connects to the area 0, the backbone area. And since we're connected logically to the St. Louis machine in area 0, we're going to get LSA type 1s flooded into area 0 from that machine. So that's why we see the 5th router here. So we see all of the routers that are in area 0 and that have flooded their Link State Advertisement type 1 into the area. If we were to, actually, let me go ahead and show you guys. So this is area 0. So what it said is that if it's an area border router, it's going to advertise routes into all of the areas it's a part of. So let's go down a little bit and see if that's true. Yep, it looks like it might be. Router link states for area 1. We have link state IDs from router 7.7.7.5 and 7.7.7.6 and 7.7, and there's 15.15. So there's St. Louis. It's advertising and generating its type 1 into area 1 as well. And the other routers obviously will correspond with the routers in that area. So 7.7.5 and 7.7.7 and 7.7.6 are the routers that are in that area via their router ID, and that's why they show up in link state type 1 under area 1. And if we scroll down just a little bit more real quick, we can go ahead and see that we have some type 1s, link state advertisements for area 3. And again, St. Louis is advertising its link state, right? So St. Louis is part of 3, and so is Austin. Austin is advertising its router ID type 1 LSA, and that's 23.23.23.23. So there was a command that you can see more information with this particular LSA, and it was the show IP OSPF database router command. So let's look at that really fast. Database router. And this gives you a more detailed account for the LSAs for type 1 in the area. So if we take a look real quick, we can see that we have link state ID 15.15.15 St. Louis. It's advertising that. Here's the link state age. Here's the number of links for that router. So Chicago is connected to St. Louis, and we have the switch connected to St. Louis, and we have Austin connected to St. Louis. So we have 3 links there. We have a link connected to a virtual link. So there's the link ID and the neighboring router ID of 23.23.23.23 for that virtual link. So Austin, the router ID, corresponds with that. And it's connected to the router interface of 172.16.20.1, which is here. It's the serial interface here on St. Louis, 172.16.20.1. So the link state type 1 advertisement gives us detailed information about what kind of links we have on that router in that area. We also have a point-to-point connection. So you see the link connected and it says point-to-point, and that's a link ID type. And then the link ID type, we will always see the router ID of the neighbor. And that neighbor ID, router ID is 20.2.2.2, and that's Chicago. The link router interface address is 10.15.1.2. That interface is here. You see 10.15.1.2, serial interface of St. Louis. And we have some metric information there as well. The stub network is a network in which a BDR and a DR is elected on. So on point-to-point and point-to-multi-point connections, you're going to see them show up as a stub network as well as their point-to-point designation, because BDR and DR elections don't take place on them. And if it doesn't learn a neighbor on that particular subnet, then it's going to put it into the LSA LSDB as a stub network, and you're just going to have the subnet and the mask attributes here under the link ID and the link data. So let's go ahead and verify, because we have some information here talking about the link IDs, and that is what we just went over a little bit. So the point-to-point link type will always be the neighbor router's ID, the neighbor router's RID. The link to a transient network is the one that we didn't see, and we're going to take a look at that. We have a link for stub network. Stub networks, the link to the network in which no DR or BDR election takes place. And we have a virtual link, which will contain the neighbor's ID. So we verified that before, so we just need to verify about the transient network. So again, virtual link, we have the neighbor's RID, and we have the neighbor's RID there and the point-to-point. And if we were to take a look at Denver, what we will see here is that we have a transit network. Here's the Link State ID for Denver. So Denver is 7.7.7.7, the advertising router 7.7.7. It's connected to the stub network. And stub networks also show up for loopback addresses. So if you have a loopback address, it will show up as a stub network in your Link State database under a type 1. And that's why here you see the network subnet number is 55, 55, 55, and that's the subnet mask of the loopback address because we didn't configure it as a point-to-point network when we created it. So that's why you see that showing up as a stub network as well. And here you see it shows up that the link of a transit network. So a transit network is a network or a multi-access segment network that will display for you the designated router on that segment. So the link ID will show you the designated router, and that's 192.168.10.1. And the link data will show you the router interface, which is 192.168.10.2. So over here, we have 192.168.10.1 is St. Louis, and Denver is 192.168.10.2. So a transit network is the network connection to the DR on a multi-access access segment. So all of these particular devices and routers are connected via a multi-access segment, so their transient network connection will all go to the DR, which is St. Louis. If we do show IP OSPF neighbor, you can see that our DR, our full DR, is 15.15.15.15, and that's St. Louis. Since Denver is the second highest router ID in the segment at 7.7.7.7, it's the BDR, and that's why we don't see a BDR here in any of the states. We only have druthers. So if we was to go to like Aspen, for example, and do show IP OSPF neighbor, we'll see that the BDR is 7.7.7.7, and our DR is St. Louis. If we do show SPF database and we go do router again, you get to see the transit network link connected to it, and it's going to have the designated router address, which was St. Louis. So the type 1 LSAs are flooded throughout the area. They tell you about what kind of connections those routers have. And if you look at the link ID, it lets you know what kind of connection type is going on there, whether if it's a multi-access segment connection and it's going to give you the DR, or whether it's a point-to-point connection, or whether it's a stub connection because there's a loopback interface that's enabled, or whether or not there's a BDR or DR election that's taking place on that particular point-to-point or multi-point connection, or whether there's a virtual link that's taking place and connecting a area to the backbone. So those are some of the link IDs that you will see with the type 1 LSAs. And again, the type 1s tell you about what routers are in that particular area and what are their router IDs. And if you drill down and use the show IP OSPF database router command, you get to see more detailed information about those connection types. So let's go ahead and move on to our second type of network link state advertisement, and that's type 2, and it's called the network link state advertisement. And really quickly, let me go ahead and just give you guys some information about type 1s. The type 1, and this is for link state advertisements in general, they're reflooded every 3 minutes or 1800 seconds. So OSPF will send out these link state advertisements to all the routers every 30 minutes, and they refresh the link state advertisements that are already in the database. If for whatever reason that database link state advertisement isn't refreshed after 3600 seconds, that link state advertisement is discarded. If you wanted to actually discard link state advertisements manually, then what you would do is flood out those link states with a max age value of 3600, and once those routers receive that advertisement with that max age, it would discard those link state advertisements for you. Okay, our next type of link state, again, network link state advertisements. These are generated by the DR on the segment and are flooded throughout the area. So when it comes to type 2s, they're generated by the DR, and they are flooded to all of the routers in that area. Since the routers in the area are only formed adjacencies between themselves and the DR and BDR, these type 2 LSAs are used to inform those routers of other routers in the area. So say, for instance, we're on Denver. Denver has no idea about Cold Spring or Aspen. It doesn't know about those until it receives the net link state advertisement from the DR on that segment, which is St. Louis. You have a couple of commands. Again, you have the default show IP OSPF database will give you a basic summary information about that link state advertisement, but then you also have the show IP OSPF database network. And that gives you more detailed information about that LSA. So let's go ahead and take a look. So say again, we're on Denver, and we do show IP OSPF database, and that's what we want to do first. Here's our net link state for area 1. And it's going to show us the link ID of the designated router and the advertised router ID of the designated router. So 192.168.10.1 and 15.15.15.15. That's the designated router. And give me 1 second. Sorry about that. We can go ahead and look at some more detailed information, but let's hop on Aspen really quick. We could do this as well, and we're going to see that our net link state is again going to be our designated router ID and our router ID and our IP interface of that designated router. So we're going to get that from all of these particular routers in this area. So again, if we wanted to see some more detailed information and figure out, well, how is it that Denver knows about the other routers if this is all that shows up when you look at the net link state in a database? Well, this is just a summary. So for instance, on Denver again, let's go ahead and do the full command, and we're going to go ahead and do network. Okay, and notice that for Denver, here's the net link state type 2. We have our link state age, which is 879 now. We have the link state ID, which is the designated router, of course, and the advertising router, which is the router ID of the designated router. And we have a network mask in the attached routers. So this is where it gets its information about what routers are also attached to that DR. We see that the attached routers are, well, 15.15.15.15, that's that router. And it's also attached to 7.7.7.5 and 7.7.7.6 and 7.7.7.7. So those are the corresponding 4 routers in that area. So if we were to go to Chicago, and let's do show IP OSPF database and network. Chicago is connected to Detroit via a multi-access segment, and there are the two routing IDs. It says the Link State ID of the designated router is 10.10.2.2, and the advertising router is 20.2.2.1. So the DR is 20.2.2.1, even though we have an attached router of 20.2.2.2. So on this segment, the router that has the highest router ID is actually not the DR. And that's only the case because I actually set the priority so that I can actually force that to be the case as a test. So if we did show IP OSPF neighbor, you'll see that 20.2.2.1 has a priority of 255, which is the highest it can have, and it forces it to be the DR. So I did that because I wanted to force Detroit to be the DR with a lower route ID, because that's what you do when you're learning. You force stuff that take place. So that's what the network summary or the network link state ID type LSA is for. It lets you know, sorry about that, it lets you know about the routers in the segment from the DR's perspective, and which routers are attached to it. So let's go ahead. Our next type is a type 3 network summary. I think I skipped it. There we go. Type 3 LSAs, or network summary link state advertisements, is a summary of addresses outside of the local area but within the OSPF domain. The only information contained in the LSA are the network IP prefixes. They are generated by the ABR and flooded into all adjacent areas. And we have an additional command, obviously, that gives us more information. It's the OSPF database summary. So let's go ahead and take a look at this. So type 3, obviously, what it said is that it gives us the information about the networks that are outside of the domain that we are a part of. So again, let's go to Denver because we're beating up on Denver. I like Denver. We're going to go to, I've never been, but I do like it. I want to go. I have friends who've been there, and for years they've said it was a great place. And let me get back onto what I'm doing. Here we have our summary net link states type 3s for area 1. So in area 1, we get to see that there's a lovely world of networks that we know or wouldn't know anything about if it wasn't for St. Louis, which is our ABR flooding these networks into our area. Again, remember about OSPF, the areas are set up to keep things segmented in case there was an issue with area 1 and a route was lost or a link was lost. You don't want to have SPF going and running across the entire network, across other areas. You create areas to segment off the network and keep it confined so that the network can grow. And if there are issues with this area, it's not going to affect all the other routers in different areas. And that way you're efficient and you're able to grow and you're able to specifically handle issues or do configurations on areas and keep those confined. So Denver is connected. In area 1, Denver is connected to an OSPF domain that has different areas. So Denver, if we wanted people, or if Denver needed to connect to or communicate with Austin or Neo or Detroit or England, it would have to do so because of the information that it received and learned from the type 3 LSAs. And those LSAs actually show you the subnet networks that are actually available. So all you will see is the IP prefix, like it said, of those particular networks. So for instance, we see 10.10.2.0, and that's the connection between Chicago and Detroit. So 10.10.2.0. So Denver can get to this network. We have 10.15.1.0, and that's this connection here between Chicago and St. Louis. 10.15, we're going to skip this one. This is like a broadcast for this point-to-point connection here, and that's the broadcast. We have 10.15.2.0. 10.15.2.0 is the connection between Detroit and DC. We have 10.15.3.0. That's the connection between DC and England. And we have 88.88.88.0. And that's actually a loopback interface on Neo. So loopback interfaces will show up. 3.3.3.0 is also a loopback interface. And those will show up as well. We also have 172.16.20.0, and that's the connection between St. Louis and Austin. So you can see all of the particular path and links between the other areas outside of Area 1. And this allows us to go ahead and be able to communicate with those. I mean, obviously the other link states are valuable and they're needed too, but that's the main purpose of the summary net link states, to give us the prefixes of the subnets and networks outside of the area we're in. We can go ahead and do summary, and we get more detailed information about those. So as you can see, we get like a summary address. We get the network mask, advertising router. And I'm going to scroll up again real quick so you guys can see that the advertising router for all of those routes are 15.15.15.15, and that's the area border router. So again, remember, the area border router is what's flooding this and generating this for us into our area. So it's going to be the area border router that you're in that's going to do this for you. So if you do the summary command again, like I said, you get to see more detailed information about those particular subnet prefixes. We have a network mask of 24 for the 10.10.2.0. And more information. So that pretty much covers it for the Link State advertisements. If we were to go, for instance, we would go, let's like hop on England real quick and do it. Database summary. And we get to see the connections for English perspective. So the Link State advertisements, obviously, they help. It's very good to be able to set up a topology for yourself and work on this stuff and see how they work. Here's the net link states for Area 2, and this is from England's perspective again. England is able to see what Area 1 had in terms of its loopback addresses. So there's loopback address 40.40.40.1 and 55, because we didn't see that from Denver's perspective because it was in that area. So again, with the type 3s, we're going to get the subnets and IP prefixes for networks outside of our area. And now that we're in a different area, we get to see the ones that were in Area 1. So in our next video, we'll go ahead and take a look at 4, which is for area border routers and ASBRs and where they are when they're doing their redistribution. We're going to take a look at type 5s and type 7s as well. So if you guys have any questions, let me know. Please subscribe, leave some comments. Like I said, I want to do this and do it in a way that you guys can take the most out of it. If I'm not hitting certain things, then let me know, because I'm obviously spending a lot of time to create this, and it's mostly for you guys. It's it's a refresher for me as well. But thank you guys, and I'll see you soon.